We were talking about who was going to introduce who, and I thought, does anyone actually need Dr. Venter to be introduced? And I think we could talk about, the fact that you've been a fire starter and a renegade for your whole career. You've done things people, have said could not be done. And you've inspired a whole generation of geneticists and biologists and physicists and health entrepreneurs, doctors, with your science and your ability to harness technology to understand the potential of our DNA. So my first question is, where are we in terms of collecting and parsing the data that will be required to really understand the human genome?
That's a good question. So not as far along as most people think. It's still extremely early. We're somewhere still around 1% of the knowledge that will be ultimately obtained. And that's sort of the basis of why we started human longevity, is that we could collect hopefully tens of millions of genomes, but in conjunction having phenotype and clinical records on every person. And we're using machine learning to make correlations between them. So it's the way discoveries are being made in the genome as the way genetics has been done for the last century, and it's very slow, tedious, and I would say at least half, if not 80 to 90% of the papers published in this field are wrong.
Wow.
And we made a fundamental decision when we started HLI. Well, would we use the literature to validate our data, or would we use our database to validate the literature? And we were glad we chose the latter, because our team has found as much of a third of ClinVar, which is the reference everybody uses for annotating their genomes, it is just riddled with false data. So if that's what diagnoses are being made on, that's why the genome is struggling right now, and for people to accept it, you can't get the same results from two different places. And so we hope the next couple of years will start to change that. As we get more and more people going through the health nucleus, it gives us a huge phenotype data set. And we can talk more about that if you want.
So I want to talk a lot more about everything you just said. Let's start with some of those numbers. So 1%, you say we understand, so we know or we understand 1% of the human genome?
I'd say we understand 1%.
And is that a sort of educated guess, or is that based on something?
It's more based on discovering how much we don't know every day. It means we know very little. It's not a precise number. It's just we have a very long way to go.
So the percentage that's classified currently as junk DNA, that's not junk, right?
I would classify some of the scientific literature as junk DNA.
Okay.
So there is no junk in the genome.
There's a famous paper that said, something like 60% of all research is subsequently proven wrong. You're quoting 80 to 90%. So
yeah, most of these papers don't even get quoted once, even by the author, unless they get quoted to say that they're wrong. So.
Or their moms quote them. Okay. So it does kind of boil down to databases, though, doesn't it? I mean, there's a lot of companies and projects, both public and private, that are collecting genomes and publishing literature and then deciding which literature to use to interpret the genome.
Well, it starts with the fundamental quality of the data. So we hired Bill Biggs to build out our sequencing facility 3.5 years ago, and various groups have validated that our data is the most accurate data out there. So it's not a matter of buying a machine, it's the whole process, and we've been doing this for well over 25 years now. It makes a big difference whether it's a rare variant used to diagnose a trait or a disease, or a sequencing error. And each of us have around 4,000 or 5,000 rare variants. Some have more, some have less. Rare variants means ones that we don't find in any database at this stage. So certainly, allele frequencies of less than 1 in 20,000. So when you're at that level or lower, and you're attributing something to it, you want to know that it's real and not just some sloppy lab work.
What is an acceptable degree of error in a genome? What do you guys strive for at HLI?
So when you're using it to give people predictive information, I'd say there's no acceptable level of error. The trouble is we're finding with various genetic disorders, for example, with triplet repeats, there were never really broad population surveys done. People sort of look under the lamppost, so they look at people with that disease. We're finding now, looking at a much broader population, that, for example, with Huntington's disease, we're finding people with numbers of triplet repeats that greatly exceed what would be used for a clinical diagnosis. But these people clearly do not have Huntington's disease. They have no family history of it, no symptoms of it, and maybe they'll get extremely late onset disease or something. But what was classified by looking at people with frank disease doesn't kind of extend when you see the whole population. And we have another thing with heterozygotes for ApoE4, which puts them at very high risk for Alzheimer's. In fact, we have one individual from all the genetic scores, you'd be sure this guy would get Alzheimer's disease. He's 74 right now, and he had almost a perfect brain scan, more like a 40-year-old. So the challenge is the lack of correlation at a 100% level between genetics and what we attribute to it. BRCA1 and BRCA2 are another example. It's actually a 50% risk factor for a woman to get breast or ovarian cancer, having the well-known genetic changes in those genes, unless there's family history. If every woman in your family has breast or ovarian cancer, then plus those markers, it goes up into the high 90%. So that means there's other genetic elements that we simply don't understand yet. And once we do understand them, we'll be able to tell women whether their risk is 0 or close to 100%. Right now it's 50-50 because the most important risk factors only come from knowing your family history.
So let's go back to some more numbers. I think the last time we checked in, HLI had about 2,000, is that right? Complete genomic and phenotypic information.
Yeah, we've had a little over 2,000 people go through the health nucleus.
And does that include like the full body MRIs and
yes,
the cognitive testing and all of that?
In fact, we have a new definition of it. February 1st, we're rolling out a new product, but we're handing out brochures on it because there's a special on it here for people.
$4,950. Okay, that's a big discount off of 25.
Yes.
Okay. So what are we not getting?
And it's the whole body MRI, the quantitative brain analysis, quantitative vascular analysis. The new Siemens MRI actually does a pretty extensive cardiac analysis in 12 minutes, and the report is done by the time you get out of the MRI. Perhaps the most important thing we're finding, because it's such a huge percent of the population, is greatly elevated organ fat, primarily liver fat. Normal is 4% or less. We've had people as high as 38% without knowing it. And so we're trying to estimate how many of those go on for fibrosis and would need liver transplants. We found a correlation between the microbiome and fatty liver, so I think that's important. And what the special deal is you get a free microbiome analysis if you do things at Startup Health. It was a partner with us. But so it's the full genome, a number of lab values, particularly we use a thing called Quantos that measures insulin sensitivity. It's with metabolome. We do cardiac CT for people over a certain age. And what we're finding there is the age groups where we're finding calcium in the heart keeps going down. Recently we had a 45-year-old woman that was clearly not obese, no history of heart disease. She was in the 99th percentile for 4 different coronary vessels, wow. Which means she's an extremely high chance of having a major cardiac event in the next decade. She did have elevated blood lipids. But these unusual cases give us, fodder to go back and look at the genome of these individuals as well. But we're finding a shift in all diseases to younger and younger cohorts, cancer as well. But as you probably know, cancer has been replaced by heart disease in women as the #1 killer. And most women don't consider heart disease a woman's disease. Most physicians don't. And so it's getting neglected. But the kinds of tests that we do make it very clear whether you have it or not.
So at $25,000, I think going down to do the full Monty on yourself as a healthy person was a bit of an indulgence. And it was for, the leading edge, people who had lots of money and curiosity.
And we didn't know what to charge initially. We still have, so the new version is called HNX. We still have the HNX Platinum that people still ask for. And it's a full 8-hour one. This takes 2.5 hours to go through everything. So it's a big difference in time and dollar commitment, and you can use health savings plans to pay for this.
Cool.
We're trying to get enough data where it makes sense for third-party payers to pay for it, but preventative medicine is hard to sell. But we just did a study on 25 people for a pharma company, sort of average age. So out of 25 people, we found one with a very serious cancer that they didn't know they had, a couple with serious heart disease, and a spectrum of other diseases. So all of which would have, they're self-insured, so they would have had to pay for these once they revealed themselves. So. We're finding 1% of the population have brain aneurysms. And our MRI is nice because it's no contrast, so you can have an MRI every day with no risk. And brain aneurysms, most people know somebody that's died from one. They can generally be treated as an outpatient, just threading up a coil to put in them. 5% of people over 50 were finding a major tumor that they didn't know they had. The good news is we're finding these at stage 0, stage 1, and some at stage 2. Thus far, they've all been successfully treated. All the diagnoses were confirmed by the pathology, so we're doing really well with diagnosing things in the MRI. And we now have a machine learning algorithm that's as good as the best pathologist for scoring high-grade prostate cancer, straight from the MRI. And We think in a year we will have the same thing for breast cancer, switching from doing mammography to MRI for breast cancer, which will be a major shift, particularly with no contrast media. So mammography has a huge false positive and a false negative rate. So we think getting this data with machine learning is really changing what can happen.
So, so it's a fantastic thing to do on a preventive basis to find out what may be lurking in your body, a little time bomb or something that you could do something about. What about discoveries? So have you been able to discover some correlations that were previously unknown? Have you...
So we don't view what we do as diagnostic, because everybody that comes in is by their definition healthy.
So that's the question I'm getting at too. So as a consumer, $5,000 is still, a fair amount of money. I'm not sure I would come unless there was something wrong with me that I was trying to figure out, in which case I might come to you instead of going to the Mayo Clinic.
But that's the wrong way to think about preventative medicine. It's like you're not going to ever change the oil on your car until all the oil drains out and your engine freezes. Because then you know something's wrong.
Yeah.
With these cancers, with the early detection, as I said, we've been 100% successful thus far in treating them. All the individuals are cancer-free. We have a cancer exome program. We're dealing with 4 women in their 30s with stage 4 colon cancer. When you detect cancer from symptoms, the outcome is totally different. So getting pre-symptomatic early discoveries, your odds are pretty high. If you're over 50, 5% of people having a cancer they didn't know they had is pretty stunning. And in fact, we're having to re-educate the medical system. So we diagnosed one man in the 70s as having a high-grade renal tumor because we use our algorithm as post-processing with no contrast media. He went to a clinic up here in the Bay Area and was told, they put him through a standard MRI, and he was told he just had cysts and to ignore it. So we found somebody here in San Francisco that knew how to read this new technique and confirmed that he actually had renal cancer and was operated on a week later, and it was confirmed that it was a high-grade tumor, not yet metastasized. So most of the medical community is not even aware of these new techniques that you can do non-contrast MRI with all this post-processing algorithms. But you would be smart to go through, because then you become a baseline. You're your own control level for things. I can give you an example with myself. I was discovered to have high-grade prostate cancer last December. And this was after a long period of having elevated PSA, having biopsies, being told they didn't have prostate cancer. Also, one of my blood tests showed that I had extremely low testosterone levels, which is bizarre because nobody's ever accused me of being low on testosterone. And what turned out, trying to understand my tumor, we went back through my genome and looked at the androgen receptor. And so it's a triplet repeat phenomenon. So if you have 21 or more triplet repeats, you have a very low incidence of prostate cancer. The fewer repeats you have, the higher your odds go. I had only 6 repeats. It's one of the lowest numbers. And what that causes is an overexpression of the androgen receptor. which explains why my testosterone levels were so low. It took only a tiny bit to maximally activate the receptors everywhere. So the production was down-regulated. So compared to the average population, they were low. Compared to my own personal baseline, had I known that was the situation, I wouldn't have gone on a testosterone supplement, which probably aggravated the tumor and made it grow extremely fast. So getting a baseline, and then you can detect differences annually in yourself. So we're setting up these new programs as membership programs. So once you have some of the tests, you can come back annually. For example, if you have a higher risk for cancer, and just get the whole MRI. So,
and I think you're also increasing your outreach to other organizations to help have this not just be localized in San Diego.
Yeah. In fact, we're trying to get several dozen set up in the next year or two around the country. Some are partnerships, some are being done as franchises.
So how many genomes would you like to sequence by the end of, let's say, 2018?
Well, our goal is as soon as possible to get 10,000 individuals through the health nucleus, because that gives us a really good starting data set for the machine learning of comparing all the traits back to the genome.
So what can you discover with 10,000 versus 100,000 versus 1 million?
So the higher the numbers go, the better chance of finding things with the really rare alleles. So one of the interesting things is we saturated the common alleles in the human population at about 8,000 genomes. The common alleles is what most people use on gene chips to measure things. So by the definition of being common alleles, they're not the cause of disease. The ones you want to measure in yourself are the extremely rare alleles. And so with each person, we actually give a ranking. We have a really nice tool that looks at your entire genome in 200 milliseconds. And it gives the allele frequency for that variant and our population data set. So when you're looking for things of significance, if 75% of the population has it, we just ignore it. If 1 out of 20,000 have it, we pay a lot of attention to it. We've also mapped the genome, so we know sites that are very susceptible to mutation and ones that aren't. There's places that if you have a variant at that site, it's incompatible with life. So those are probably associated with early spontaneous abortions, for example. Just mapping transmembrane receptors. If a change occurs in the transmembrane section, that usually leads to a loss of function mutation. So from just mapping the genome to combining it with this data, it's pretty exciting every day there what we're finding.
So you wrote an op-ed last month talking about the risks of gene editing. And you've been very vociferous about sort of your concern that we are so excited by the potential that we are liable to get ahead of ourselves and start editing the genome prematurely with unintended consequences. And you're not alone in that. Obviously, there's tremendous
that's no fun.
concern. And that's actually kind of unusual for you. I mean, I expected you to be out on the fringe of that debate. But how much do we have to understand about the genome before editing the germline would make sense?
Well,
you know, if we're at 1% now, you know, does 50% increase your comfort? Does 90% increase your comfort? Or do we have to know everything about the genome, the metabolome, you know, proteomics, everything before you would be comfortable?
So we need tools that are really precise tools. So CRISPRs have off-target effects. And usually people just measure the effect they want to. They don't resequence the whole genome and see what else was changed. On this latest data, the paper just came out, it's very interesting. something like 2/3 of the population have antibodies to CRISPR, and probably won't be very effective. Obviously, for germline, that's different. But you want to know that you're making changes that are, that are unique and important. I think getting rid of Tay-Sachs disease or ataxia telangiectasia wouldn't be bad ideas in the population. Kay Jamison.
Can't we just do that with frozen embryos? Don't we kind of get around that?
Once you start down this road, it's a very slippery slope. And all the polls, most young parents want to change fairly trivial traits in their children, eye color, hair color, types of muscles, versus disease risk. Kay Jamison was at Hopkins, I think she's still there, has written several books about manic depressive illness and creativity. And so if we treat manic depression as a disease and we find the genetic links for it.
I'm going to interrupt you because we're now running short on time. And
we'll wipe out all the creativity in the human population by editing that out. So we need to know all the consequences of making changes for future generations.
Absolutely. Okay. So you've signed on as a sponsor for Startup Health's Longevity Moonshot. And the definition of the moonshot was to increase average lifespan by 50 years. So, we can prevent a lot of aging through lifestyle choices. Tobacco, sugar, alcohol, eliminate the poisons, diet, exercise, sleep, stress. But we have no means of clearing the senescent cells or repairing the mutated DNA or what have you. So what do you think are the most promising avenues of research to pursue in the quest for longevity?
Yeah. About 30% of people that reach the age of 50 will die before the age of 74 right now. So when you're talking about increasing lifespan, finding a tumor in a 50-year-old that can be completely cured probably change their lifespan by 30 or 40 years if they were going to die from metastatic cancer.
So you're saying early diagnosis
we're
is going to get us
across
25
the board.
years?
So if we had a 20-something that we found that she had changes with insulin sensitivity, increased organ fat, a pear-shaped peripheral fat distribution, and elevated lipids, she can go one course where it develops into diabetes. You get cardiac complications with that. With cardiac complications, you get early brain damage and dementia. Or you can totally prevent that pathway into developing diabetes in the first place. And the same thing with heart disease, same thing with early detection of cancer.
So early detection buys us 25 of the 50 years that we're going for?
For some people, it could buy them 90 years, right? When we look at the total distribution. So we started an N of 1 program at the Venture Institute with a 16-year-old girl whose younger brother died at age 12 from a neuroblastoma. On sequencing her genome, she had multiple oncogenes that were mutated, the same as her younger brother. And her parents were sure that she was going to develop cancer. So we set up a program. She's now 18, a student at UCSD. She comes to HLI every 6 months for a whole body MRI with the goal, knowing she's at risk for cancer, of detecting it at stage 0 or stage 1. So it's like doing the preventative maintenance. The more you know early on, the better the chance of detecting things early enough. we're finding cancers just happenstance on when people come in. My colleague Ham Smith at age 84, because we set up at the Venter Institute for all the senior scientists to go through the health nucleus. So only by going through the health nucleus, we found a fist-sized tumor in his lungs. Turned out to be a very rapidly growing lymphoma. Had he not come in that day, he would have died in 6 weeks. He responded extremely well to chemotherapy and radiation. His hair's grown back. He works every day in the lab now, and he's totally back to normal. So if his appointment was 6 weeks later, so timing is everything. And if you know you have risk, you can just have repeated visits as a non-invasive checkup.
So we know, we interviewed you actually. NEO.LIFE interviewed you last year and asked you just quick questions about what your personal longevity strategy is. And in addition to avoiding toxins as much as possible and diet and exercise, sleep and stress reduction, you mentioned that you take metformin. So do you think that's making a difference? And are there other pharmaceuticals or other ingestibles of some sort that you think?
I take statins, and they've changed my cholesterol levels substantially. Metformin and a combination of diet changes, my A1C is now in normal levels, so it does have an impact. I do believe in preventive medicine, even I do risky behaviors like drive motorcycles really fast, so I now have one of these vests that if you fly off your motorcycle, inflates instantly, so you bounce down the highway instead of dying. I haven't tried it yet to see if it works. There's some great videos of it, but so I try to mitigate risk even with risky behavior.
Okay. So you probably have the most studied genome in the world in human history.
Yeah.
And I'm just curious, how long do you expect to live? I mean, you're in the business of predicting what people's genomes will say about.
No, it's interesting because the team is putting a series of algorithms together like we use with the machine learning for predicting Alzheimer's and prostate cancer. And we're using it to predict the age of your brain. From the rough studies, so I'm 71, they said I have a brain of a 40-year-old. My wife said, no, he has a brain of a 17-year-old. But I've outlived every male except my year-and-a-half older brother from my father's side of the family by almost a decade now. They all died from heart disease or a combination of heart disease and alcoholism. So I think statins and the preventive measures that I've taken have presumably had some effect.
And what would you hope to see? So let's say that you're 70 now, I think, correct?
71.
71. So you want to go another 30 years, another 50 years? You mentioned in the book, John Cumber's book, What's Your Biostrategy? You were talking about 300 years.
Yeah. So the key to longevity is not your BMI, like a lot of people think. It's your muscle mass. So the key is trying to maintain strength. As people get more and more frail, they fall, they break bones, then they get hospitalized, and they sort of start a slippery slope. The data shows if you can maintain strength and activity, we all have sort of a fixed decline. It's a question, can we change that slope? And the number one risk for almost every disease is your age. So our risk goes up. So After 50, I plan to go through the health nucleus at least every 6 months,
Wow.
As preventative measures to...
Because of your history with prostate cancer and melanoma.
History, so you have to go at least 5 years with negative PSA to really be proven that you didn't have a metastases from the surgery. But I've had melanoma, I've now had prostate cancer. I have a few oncogenes that are activated, so I'd like to detect things as early as possible. The algorithm for predicting what year you're going to get Alzheimer's is really getting pretty accurate. I'm pretty far out on the curve on that, at least 20 or 30 years out. So,
but you do have an algorithm for predicting that.
Yes.
Okay.
And that'll be part of the program that we start to offer people in the near future. If I could still be riding a motorcycle at 120 miles an hour at age 102, I think I'd be happy.
Is that your expectation?
I'm going to try.
What else would
Maybe
you...
my last motorcycle ride. But it's,
What would your... What would you hope to see happen in your fields, whether it's genetics, longevity, synthetic biology, in the next 30 years? What do you want to see happen before you die?
So the biggest challenge, and I didn't realize it would be such a huge challenge, and you're an example of it because you were hesitant to do these tests, is getting people to do preventative medicine.
That doesn't sound like a moonshot.
It's a Jupiter shot or something. The moon would be easy by comparison. If you look okay and feel okay, you deem yourself healthy, and the medical establishment deems you healthy. You can't tell me you're healthy. I can tell you whether you're healthy or not after going through the clinic. I can tell you whether you have cancer, whether you're developing early dementia, whether you have metabolic disease, all of what you could be completely unaware because it's at stages that haven't started yet. The 1.5 million people that get diagnosed each year with cancer didn't just get that cancer the day before. Mm. Some of them have had it for decades. So the medical establishment is fighting screening healthy people. Mm-hmm. And it sort of stems from the 1970s when CT scanning came out. CT scanning is just X-ray, and it created what were called incidentalomas. You couldn't tell a tumor from a cyst.
So, but give us something bigger to chew on here. You announced a DNA printer last year, right? Mm-hmm. We could email a file to some off-planet colony and print, humans or at least vaccines or something. Mm-hmm. So, how far out can you imagine something outrageous happening between now and the end of your lifespan?
Well, if the 40% of men that die before they reach 74 get preventive medicine and don't die, that changes the economy, that changes productivity.
What happens to innovation if all the old people hang around longer?
Well, it's not working so well in the government right now, but I think we need some younger people in the government, at least at the top. But look at the list of top people and still in the prime of their lives that die each year. Mm. We're losing that knowledge, and we sort of have to start with each generation and reteach them all the things like vaccinations are actually important to keep disease away and things. So I think if we made preventative medicine and using these new tools of science to find out whether you're healthy or not, is actually probably one of the most important things I could accomplish in my life, and particularly if the genome makes that predictable as a triage, that would be pretty satisfying.
Great. Thank you for your time.
Thank you.
Okay.